Hello, this is the Karl Storz capstone project consisting of 5 UCSB mechanical engineering students, Adam, Dylan, Eric, Jason, and yours truly, Alfredo. So this year, Karl Storz, or KSI for short, has entrusted this team to create a fully autonomous reprocessing device for their endoscope samples. Let me explain. One of the products that Karl Storz and Kalita supplies are endoscopes, which are basically cameras used for minimally invasive surgery. And these endoscopes have to go through a heavy reprocessing cycle, which basically can degrade the outer coating and making the device unusable due to FDA regulations. So our job is to basically mimic this reprocessing cycle and automate it in order for Karl Storz to perform accelerated tests on their endoscopes and improve their devices. So since there are 3 stages in the reprocessing cycle called cleaning, sterilization, and sanitation, there will be 3 chambers for the device. For the scope of this year's capstone team, we will be making the first cleaning chamber along with the automation for a radial arm, which will bring the samples from chamber to chamber. Now, without further ado, I present to you the accelerated endoscope degradation. So first, let's talk about this radial arm with 2 degrees of freedom, which consists of a servo to rotate the arm in the theta direction and a stepper motor to act as a linear actuator in the Z direction. Finally, we have an electromagnet to grab the test basket. Next, let's go to the custom chamber, which has a powerful non-bag drivable worm gear motor to keep a watertight seal along the lid, 2 solenoid valves to control flow rate of the water, a peristaltic pump to bring a neodisher for chemical degradation, heating pads and a thermocouple for thermal degradation, an ultrasonic transducer and pressurized jets for mechanical degradation, 360-degree valves for chamber rinsing, and of course a ball valve for the drain. Sheesh. 2 custom PCB boards, one for which all the logic power sits in between the Arduino Mega and the Adafruit motor shield, and one which acts as our power PCB board on top of that. Our MATLAB code also has a graphical user interface, or GUI for short, which basically allows the user to easily change the parameters of each cycle. With these changes, each parameter is able to be concentrated and tested individually.